Hello, grade 12s. I believe you guys are doing pretty well. Um, as you are very much aware that on your math paper, you'll be having question one, which is going to include the simultaneous equations, exponential problems, such problems, quadratic equations, and factorization and simplify, and most importantly, number patterns, functions, well, trigonometry for some of you, and also Euclidean geometry for some of you, because you will be having one paper, question one and question two. I mean, paper one and paper two combined. So we still have to make sure that we cover those topics. Now, function will be one of the topic you will really have to revise very thoroughly. Okay, so in this lesson, we are going to look into function problems and try to answer Eastern Cape question paper as they wrote it in September. That was 2016. Where were you back there? I was very much alive and I was out of matric already. In this case, guys, you look at this problem and you have to look at how it looks like very carefully, um, because you have been given the turning point and a random point and also a straight line. Now, according to the statement, they said the sketch below, which is not drawn to scale, shows the graph of f of x, which is ax squared plus bx plus c in a straight line g. And it passed through the origin. And there was a y-intercept which passed through 0 and 4. And point A, which is -3 and -5, was the turning point on that graph. Now, one of the most striking things, as we also discussed last year in grade 11, is how they can just give you a very naked equation and they will expect you to find the value of A, B, and C. All right, so I want us to dive into that to make sure that you and I are on the same page, because these are the type of questions we need to look at so that when the exam comes, you will not be surprised. Okay, so I'm going to remove this and I'm going to take you through my board so that you and I can definitely work together. I'm going to take you guys here and you will definitely work with me. Now, let's see. Well, as a result, as we are going to talk about the parabola, you will actually remember that we have three types of equations. So I'm going to say three types of forms, three types of forms of equations. And the first one will be looking like this. Y will be equal to A x squared plus B x plus C. Well, in this case, this is the form which was given on that question. All right, and you will now have the second one. The second one will look like Y will be equal to A x minus B, or I can say P if I want. Let me use P squared, then plus Q. And you must know what P and Q are for. All right. Then we go to the second form, the third form, which is Y will be equal to A into x minus x1, x minus x2. We will be using these three forms to tackle every problem should they say find the missing values in the equation. Now, I want to take you guys here. I want you guys to look at the very first form, and I'm going to need you to pay close attention. The first form, you are going to use the first form. For example, should they say find the value of A, B, and C, you cannot use that equation if we are going to give you a graph that has the turning point. Absolutely no. So I want you to learn the type of a graph and the type of an equation provided. So suppose I'm going to give you a graph that looks like that, and we give you the intercept. I'm going to give you this intercept and that intercept, and somewhere with a random point. Well, you are definitely going to use the first equation because we gave you two intercepts. You only need two intercepts. So in that case, you will then have to use the third one to get the second one. My point is, you can use these two forms to find the first expression, and you can use the third one to find the first expression. So it will be difficult if you have to use this specifically, because at some point you have to use the simultaneous equation. So when it's like that, you will then go to the third point. This is when you open two brackets like that. This is your x minus x1, x minus x2 with your a. Then this point, suppose this is -1 and this is 2. Your x1 will be -1. Your x2 will be 2. Right. And then in that case, you then have to use the third formula. You'll have to use the third formula. For example, should we have these numbers, then we have x minus 1, then x plus 2. You will now simply have to multiply, and then you will get something like x squared, maybe minus 2x, and then minus 2, something like that. So you just need to know which formula do I use given on the shape of the graph. Now, let's look at the second one. As I have written it there, looking at the second, and it's been given as y is equal to a x minus p squared plus q. Then you know that, all right, I know that these two, the p and the q, will represent the x and the y of the turning point. So your turning point will have p and the q. Let's take an example. Suppose I draw the graph and I give you the turning point. I give you the turning point. Let's say maybe your turning point is -1 and 2. Then I give you maybe a random point. Well, in that case, you will have to use that formula. You don't have your a, however, remember I said your x will represent the p on that equation. So you'll have x minus your p there, it's -1. However, because of the negative and negative, you will simply have x plus 1 in that equation. X plus 1 in that equation, then square it. And the p will be represented by the y on that turning point. Then you'll have a 2. You then use a random point to substitute your x and y in order to find the value of a. So this is how you find the value of a and the value of a certain letter. So you must look at how the graph looks like. For example, we can give you a graph that has two intercepts. We can give you a graph that has a turning point but doesn't have intercepts. So you just need to check the shape of the graph and the equation that you have to use. Right. I hope it makes sense. And we're going to have to go back to our problem and see how to work with it. Okay, I'm just going to put it back here so that we understand each other, so that we can also see how our problem looks like. Now, let's go back to it. As you can see, as for our current graph, we can see that we have a turning point and a random point. Based on the three formulas, if I may ask, which one do you think we have to use? Well, you guessed right. We have to use the second one, which is y a x minus p squared, then plus q. You have to use that formula because you have a turning point and a random point. It will help you to find the a, and it will help you to find the p, and it will help you find the q. Okay. Now let's go to our questions. We will get there. Now, the first question was write down the equation of the axis of symmetry. Well, by now you know that when we talk about the symmetry, we talk about the line that will cut your graph into halves. Okay. So in other words, when they say symmetry, then on your turning point, you must tell them the value of x. Your value of x will represent the symmetrical line. All right. If you remember back in grade 8, they will draw something like a star. I know my star is going to look shady, but they may do something like that and say, well, show us the symmetrical line. This is when you try to divide or to cut that shape into half so that you have 1, 2, 3 edges, 1, 2, 3 edges, and then you succeeded into cutting this shape into halves. So when you have a parabola will be cut like that, and you must tell them where this line passes on the x-axis. So looking at our graph, already we have our equation of the symmetry as it is here, and it will be represented by the x on your turning point. Then to answer that question, you are simply going to say x will be equal to -3. That will definitely be your answer to that question. So now let's go to the next question. Yes, show by calculation that a will be equal to 1 and b will be equal to 3. Well, you are not going to do that unless you are going to remember what I just told you not long ago. So let's go and work together. I'm going to place this here. Then you and I will work together on this spot. All right, well, let's dive into it. Well, I told you that we have to use the second formula. It can help us to find those values. When having y will be equal to a x minus p squared plus q, already we know what our p and q are. Then we say y will be equal to, we don't have the value of a. They said we must prove that it will be equal to 1. Well, then x minus, well, our p will be represented by the x on that turning point. So it will be -3. So negative and negative, because it will be like that. So I'm just going to say +3. I'm just going to say +3. Then you square it. Then your q will be -5. Your q will be -5. Then you need a random point here, which is 0 and 4, to substitute your x and y into the equation. So let's go and do that. Our y is 4. Then we say equal to a. Well, your x is 0 now, plus 3, which is automatically 3. Then you square it, and then you say -5. Well, as a result, you have 4 will be equal to, well, you have a. Then if you check, you have 3 to the power 2, which will give you 9. Will give you 9. And then you have -5. You have -5. Then as a result, you have to say 4 will be equal to then a multiplied by 9. That would be 9a. Then minus 5. Well, you'll have to transpose or to take your 5 to the other side. You will have 4 plus 5 equal to 9a. Well, as you can see, and I believe you can agree with me there, if you check, you will definitely get this 9 will be equal to 9a. You divide both sides by 9, then your a will be equal to 1. Then that's how you are going to get that. So your a will be 1. So what they wanted was a and b. Remember that b is that point over there, is that point over there. Is that letter over there. So what you're going to do, my good learner, is to remember that we now have the equation y will be equal to your a is 1, and based on that formula we had x plus 3. If you remember, you can just 1 back and then squared minus 5. Well, you'll have to expand this. Well, after expanding, you'll get to see which number will be before or will be the coefficient of that x in the middle. Well, you and I will agree here. We'll have to expand this thing. You will have to expand here. It's minus 5. You expand and then you go x multiplied by x. That's going to give you x squared. X multiplied by 5. Well, that will give you positive 5x. 3 multiplied by x. That will be 3x. And then 3 multiplied by 5. That will give you 15. Then minus 5. All right, so let's keep going. We get x squared. Sorry about my bad handwriting. Then as you can see, you will definitely get, is it an 8? Yeah, that's 8x. That's 8x. And then as you can see, 15, unless if, I hope I didn't miss anything there. Hope I didn't miss anything. Our a it's 1. And then we have to say 15 minus, that's going to be 10. And I don't think it's 10. Let me just check correctly. We need to get a 4. And we need to get b as a 5. Okay, we need to get b as a 5. Okay, so in that case, I'm just going to check. Just have to check. Okay, let me go back there just to see what might have went wrong. Oh yeah, yes, here's my mistake. I placed a 5 there. It was not supposed to be 5. Let me show you where it was supposed to be 3. My apology. I was looking at that one. Okay, so in that case, we will get this. Let me just eradicate the whole thing from here. Yeah. Okay. All right, then let's see. Then from there, we say y will be equal to, well, that will be x squared. 6, yeah, we will now get positive 6x because it's 3x plus 3x, yes. And then from there we get a 9, and then minus 5. Well, you will definitely agree with me. Then you get x squared plus 6x. Well, 9 minus 5, that is 4, as I expected. I expected a 4. I will show you why I expected a 4. So as you can see, therefore, your b will be equal to 6 because you have to look at the location of where the 6 is. Your 6 will be a coefficient of x. So it will be a 6. Let me show you why I expected C to be a 4. Because C will represent a point where the graph touches on the y-intercept. Okay, well, I believe you got that part very, very well. Now let's go to the next question. Now they said, discuss the nature of the roots of f. Discuss the nature of the roots of f. Well, when we talk about the nature of the roots, we think about this. Let me just place this board here. Think about this, or remember this. Every time they talk about the nature of the roots, they want you to imagine the formula that is inside the quadratic equation, the b squared minus 4ac. Okay, this will represent the nature of the roots. So for the sake of time and for the sake of this question, I'm not going to discuss what irrational is, what a perfect square is. I'm just going to work this problem, and then we will check the answer and decide whether it's irrational or what, or equal or not equal. So as a result, well, here's our formula. We found our formula, which is f of x, to be x squared plus 6x plus 4. As a result, we have to look at where or what is our a, and what is our b, and what is our c. Let's go and do that. Well, our b in that equation is definitely 6. You square it, then you say 4. Then your a is 1. Your c is 4. Well, then you go, well, that's going to give you 36. 6 squared, 36. Then you get 4 multiplied by 4, that is 16. Yes, that's 16. And then as a result, 36 minus 16, that is 20. Now we need to decide whether 20 is irrational, rational, unequal, or non-equal. By the way, looking at 20 itself, if we were to put the 20 inside the square root, we are going to get 2 square root of 5, if I'm not mistaken. 2 square root of 5, right? 2 square root of 5. You just go to your calculator and check. So because of that square root, we will definitely say it's irrational, right? It's going to be irrational. It's going to be irrational. Go and study the words irrational and rational, what they mean, irrational, because of the square root. It cannot be rational, because rational would be a fraction. For example, if we get something like 4/5, if our answer was a fraction, we will say, well, that is irrational. But if it's just a number, well, that it's irrational. And again, it's not equal to 0. Since it's not equal to 0, then it's unequal. It's unequal. Well, if we got something like 36, then we will say that is a perfect square. You know, that is a perfect square, because 36 will be produced by 6 times 6. It will be a perfect square, right? So in that case, we answered our problem. Now, here's another interesting question. They said G is a tangent to F. G is a tangent to F, and the gradient of line G is 2. They're saying this line is a tangent and has a gradient of 2. Now, since the gradient is 2, determine the coordinates of the point of contact. Yes. Now, if you and I, remember, these two graphs will intersect somewhere. And since it's a point of contact, then we remember from grade 11 that we need to take the graph of f of x and equate it with the graph of g. My learners, the graph of g, it's a straight line. It's y equal to mx x plus c. As a result, the gradient is already at 2. You don't have the value of c. So in that case, this is your graph of g of x already. Then this side, you'll have your x squared plus 6x plus 4. Now, this is where you will feel like you can fly without wings. This is where you will feel like you can just finish metric already. Because now you have your c, you have your x, which it's not going to be so nice trying to solve this simultaneously. And it's not going to happen. You can try, but it's going to be tricky. So this is what I'm going to do. I'm going to teach you something called derivatives. Okay, it's something new. That's why I said you are going to learn something new in grade 12. So I'm going to pause here, and I want to take you guys to my board again so that we can learn how to work with the derivatives. So I'm going to remove this, and I'm going to take you through. I'm going to share my screen with you guys, and as a result, we are here. Let's talk about derivatives. Derivatives. Some of you may have been exposed to these derivatives. Very, very important. They are part of calculus. You'll be doing this in calculus. I'm going to need you to listen carefully. This is how they work. They say if we give you a number as a coefficient of x with an exponent. I'm going to give you an example, by the way. I'm going to give an example. The n, let me say e, to represent the exponent. They work like this. They say, so this is like having something like 6x to the power 2. Okay. So the number before the x is the coefficient of x. You have to take your e and multiply with your n. So e multiplied by n, it's going to be en. You keep your x. And when that happens, the value of e, whatever number that is exponent, will have to subtract a 1. Then you are done. It's going to make sense when we look at the number. Looking at this example, you take your 2, you multiply by 6, you get a 12. Immediately, your 2 will have to subtract 1. Then you'll have 2x to the power 1, or just 12x. This is how derivatives works. Okay? Now, we're not done. Let's talk more. Suppose I say, determine dx for the following equation. Y is equal to 4x to the power 3 minus 2x squared minus 7x plus 4. I'm going to need you to listen very carefully because I'm doing this example, then we are through. When they say determine derivatives for the following equation, y equal to, you start by saying dy over dx, then that will be equal to. Then that's when you start. Well, 3 multiplied by 4, that's going to give you 12x. You must subtract 1 from that 3. Then you have a 2. Then 2 multiplied by 4, 2 multiplied by 2, you get a 4. Then x, well, you immediately subtract 1 from that exponent, then you get a 1. Then listen carefully. Every time, this is going to work every time. Every time you get a number and an x, you just take that number. I will show you why. And then you forget the constant number. Listen carefully, because this is in the dotted commas. Constant number. All right. The reason why I said it's 7, it's simply because if we have to derive 7x, there is a 1 there. 1 multiplied by negative 7, that's negative 7x. Then 1 minus, you subtract 1 there, and then you get a 0. You get a 0. Then as a result, negative 7, any number to the power 0, it's 1. So you don't need to do that, and the answer is negative 7. So every time you see a number that has an x, then you just take that number, and you don't write a constant number on your dy dx. Then this will be the end of your problem. You see, it's something short, but we learned it, and I'm glad that we understand. Well, there is a reason why I did that, and I'm going to show you why. Let's go back to our problem, and we will see why I had to teach you that. Well, as you remember, we had to determine the point of contact. Just going to, we had to determine the point of contact. They said G is a tangent to F. The moment they say is a tangent to F, you know they will have to cross or touch at some point. And we know that to find the point of intersection, we had to take the graph of f of x and equate it with the g of x, which we learned that the f of x is x squared plus 6x plus 4, then equal to. Since the gradient of g of x was 2, and we know that the equation for the straight line is mx plus c, the gradient is 2, then x plus c. That is why I'm going to say 2x plus c. You are going to remember this step next time, because this is where you will have to use derivative, okay? This is when you say, well, I'm going to derive my f of x. You put an f with a small 1 on top of it. This is to represent that you are going to do dy dx for the f and for the g as well. Then that means 2 multiplied by 1 on top of, 2 multiplied by 1, the coefficient of x, which is just 1. Then you get 2x. You subtract 1, then 2x to the power 1, or you can just say 2x. Then plus. What did I say about the x and the number? I said just take that number, which is positive 6, and you do not include a constant number. Then you go to the other side. What did I say about the number and the x? I said you take only the number, then that will be 2. It doesn't matter whether this is a c. Even though it was an 8, I will still exclude it. So even now, we are going to exclude that c. Then we have to solve x here. Then you have 2x. You take your 2 to the other side, which is going to be 6 minus 2 equal to 0. Or let's just take 6 to the other side instead. Get a 2 minus 6, which is negative 4. Then you divide both sides by 2. Then your x will be equal to negative 2. That means a point of intersection, you have negative 2 as an x. Then you must take this x and substitute into one of the formulas. Well, you cannot substitute into the g because it's not finished. You will have to substitute that into this equation. So let's go and do that. If we were to substitute that negative 2, we say y is equal to negative 2 squared plus 6, negative 2, then plus 4. As a result, 4, negative 12 plus 4. Then as a result, you get 8 minus 12, which will be negative 4. Then this is a point of contact you are looking for. Well, I believe everything was explained plainly, If there is something that you are lost with, then you just have to let me know so that I help you guys. Now, as a result, stay tuned for more problems as we will still have to work with functions that has locks. Then we need to understand what that means. We need to understand how to execute such problems. So stay tuned until we meet again.